Hello, everyone. Who are innovators, and could artificial intelligence one day replace them? For anyone familiar with the innovation process, this question might sound almost sacrilegious. Each year, various organizations and publications release lists of the most groundbreaking innovations and the most influential innovators. But what if, one day, robots powered by AI top that list of innovators forever? Everything in our handmade world, every material object, exists thanks to innovation. From a simple nail to a Mars rover, from cranes to manufacturing processes and marketing methods, all of it is a product of innovation. Innovation propels us to the next level of development, and without it, our civilization faces a grim future. That's why we celebrate innovators, why they're cherished, and why they often become legends. And now there's this idea that we could use artificial intelligence to make innovation independent of human input. Continuous, relentless, and not just moving us to new levels, but actually changing the very course of civilization's development. To do this, we'd need to build autonomous innovation engines powered and controlled by AI. But is it even possible to replace the most creative of people? Let's take a look at whether this idea is even feasible, and if so, how it might work in practice. We'll explore some real-world models, ideas you could take and run with today. And then we'll look at concepts bordering on science fiction. Personally, I think these almost sci-fi solutions are the most exciting ones. Either way, there'll be plenty to ponder, so stay tuned until the end. At its core, innovation is simply an idea brought to life, and we know that neural networks can generate new ideas. If we set up an AI-based idea generator with a large language model, providing it with the right data and automated control, it could continuously generate innovative ideas. This would be the first, most achievable part of our plan. The setup could look something like this. The core would be a powerful language model trained on all the knowledge that could be useful for analogy and pattern recognition. It would need to be a truly universal model, as smaller ones lack certain capabilities for processing complex information. For this, we could use a flagship chatbot model available via API, with the option to create and fine-tune specialized models on top. The model needs further training in the specific field where the innovation engine, its first component, the autonomous idea generator, will operate. For example, we could use all the books, textbooks, and scientific publications on industrial construction or a specific area within it. The input to the model would include 3 agents. The first agent monitors available information sources, like the internet and digital libraries, to catch the latest achievements and observations. The second gathers and feeds the central model with historical and current information from the company, including feedback from employees solving day-to-day issues, as well as input from clients, contractors, and users. While these two provide the core with information, the third agent manages it, sending prompts to enable the process of generating, filtering, and evaluating ideas, something I've described in another video. From the model, we get a list of ideas for improving the chosen process. These ideas are not just stored, but fed back into the system via the agent managing current information, looping them back into the core model. And why would we do this? So the model knows what it has already proposed. It could then compare and rank new ideas against old ones, while also synthesizing ideas from previously suggested concepts. In the end, the idea generator produces a list of innovative ideas, ranked by criteria such as novelty, feasibility, and expected effectiveness. Could a system like this work without human input? Not yet, at least. Clearly, the operator of this idea generator would need to be an expert in the field in question, ideally an innovator themselves, a creator of new concepts. And they would certainly need to be skilled in prompt engineering. First, the operator controls the idea generator through agent settings, especially using prompts to ensure a continuous generation process. The quality of the generated ideas depends on these settings. Secondly, as a specialist and innovator, the operator subjectively evaluates the ideas by the same criteria used by the language model, adding their assessments to the ranking. The operator's prompts focus the generator on problems that need clear formulation. This is the primary setup before launching the generation, filtering, and evaluation cycle. Alongside identifying solutions to the problems specified by the operator, the idea generator could and should search for issues within feedback. Any reputable company has a system for logging production situations and handling requests, along with related discussions. This system has a database, a valuable resource for analyzing and finding issues. Ideas are evaluated not only by how well they address problems posed by the operator, but also by those identified through interaction with employees, clients, and partners. But this is just the idea generator. Where's the actual innovation engine? When and how will that come into play? There's a consultancy called Board of Innovation. Every year, they host a virtual event, the Autonomous Innovation Summit. At the 2024 summit, there were around 40 virtual sessions, with nearly 50 speakers and over 11,000 participants tuning in. Autonomous innovation machines were, unsurprisingly, the main theme of the summit. While many concepts for such machines were presented, most agreed on a few essential components. Continuous operation. The innovation machine functions as an always-on system, persistently identifying opportunities and creating solutions without needing constant human intervention. AI-powered ideation. Utilizing AI's capabilities for synthesis and ideation, the machine can autonomously create new concepts, often surpassing human-generated ideas in quality and creativity. Rapid prototyping and validation. With AI, the machine can quickly prototype and test concepts, assessing their feasibility, appeal, and viability in synthetic environments before moving into real-world development. Adaptive learning. The system learns from real-time data and user feedback, allowing products and services to evolve autonomously to better meet customer needs. Looking at the example setup of the idea generator we discussed earlier, we can see that the first 2 points are achievable, while the fourth is partially covered through feedback analysis from employees, clients, and partners. But there's the third point, which sounds, to me, quite fantastical. And it really is only conditionally feasible for now. Let's take a closer look at point 3. It suggests that the innovation machine wouldn't just propose an idea, but would test it by autonomously creating and running a prototype. Does that mean connecting AI directly to machines and letting it build whatever it wants? Turns out, that's a no. Every innovation generally falls into one of 3 categories: a new product, a new service, or a new process. A new product is something physical, something you can touch. A service, however, is about interactions between people. It has providers and recipients, often involving multiple contributors in service delivery. A process can involve interactions between people, objects, or often both. For prototyping products, services, and processes, the idea is to use digital twins, as I mentioned in another video. A digital twin of a person would be an LLM bot trained to fulfill the corresponding role. This seems relatively simple, given our experience creating various virtual assistants. Creating a digital twin for a physical object or device, however, is more challenging. It involves CAD and CAE systems, the backbone of which is what we call generative design, powered, as you guessed, by generative AI. Using Autodesk Fusion 360, for instance, engineers can create real prototypes, like innovative car seats. And the NVIDIA Omniverse platform enables the creation of digital twins for entire factories, something BMW is working on. In principle, the tools for creating digital twins are available, and they are, of course, computer software. Leading chatbot developers are hinting that their next models will be able to interact with computer interfaces. They seem to be getting the hang of programming too. So the model that proposes an innovation idea might use suitable software to create a digital twin of a product, system, or service. And then test it. The test results would return to the autonomous innovation machine, allowing it to adjust the design, create another virtual prototype, test it, review the results, tweak the design, and repeat until an optimal solution is reached. In this way, based on identified problems and opportunities, innovative ideas would be generated autonomously and continuously, then prototyped and tested in the same autonomous loop, ultimately yielding a blueprint or detailed documentation ready for production. In my view, autonomous innovation machines would be developed specifically for each company, or, at minimum, for each industry, as they would require specialized information. If competition remains fierce, these innovation machines, with all their configurations and data, would become one of a company's most valuable and protected assets. Likely, there would be separate machines for product and service development, and dedicated ones for each business area: administration, human capital management, marketing and sales, supply systems, and so forth. Now, I may be exaggerating a bit. Even Board of Innovation emphasizes that autonomous innovation machines won't be fully autonomous, but will instead serve as tools managed by humans. They're careful to insert human involvement at almost every step, perhaps to reassure themselves and us. Digital twins are still quite primitive and require specialized skills and significant effort to create. Generative design outputs can also be flawed due to the same hallucinations common to generative models. So without human oversight, these machines might quickly produce nonsense and get stuck in a loop. And there aren't yet integrated systems for prototyping and testing without people to select and configure the right tools. The process still requires human involvement. Overall, while I say that all the necessary technologies exist, most of them are still in their infancy. Think of it as a wooden model of a bicycle. You can technically ride it, but not very far, not very fast, and not everywhere, and not without someone pushing from behind. Still, with the rapid pace of technology development, almost no forecast seems too optimistic. And what about us humans, these operators? If predictions come true and innovation machines become autonomous, their directions would become increasingly strategic and their evaluations would take on an ethical dimension, assessing what people would or wouldn't like. Is this sci-fi, you ask? Mostly yes. But Board of Innovation is already offering services to develop autonomous innovation machines, and those 11,000 summit attendees can't all be fantasists. Technically, all the necessary technologies are available, though they have plenty of limitations. But it leaves me wondering, autonomous factories, autonomous innovation machines. What will we humans do? Develop spiritually? I don't have answers to such fundamental questions, but I'll keep an eye on information technology and continue sharing my observations. So stay tuned, comment, share your thoughts, and don't forget to subscribe to my channel.